Action!
All right.
All right, welcome, ladies and gentlemen. That is right. We're talking about angles and degree measure. There we go. So first of all, talking about angles. So you've seen an angle before. It's formed by two rays that share the same initial point. All right, initial point. This is sometimes referred to as the initial side. And this would be the terminal side. And an angle is measured as it's kind of like a measurement of the rotation between those two rays is what we're talking about. Right? And this angle will abbreviate with the Greek letter alpha. Looks like a little fish, maybe, goldfish. Fish snack smiles back until you bite their head off. Here we go. Also, this point is referred to as a vertex. But we've seen vertices before in Math 4, right? Am I right? Yeah, we have. We have.
Wait, what's that thing underneath the vertex? Not that vertex, the vertex of the... Oh, that's an arrow?
Yeah, that's just a sad-looking arrow. I should have chosen different colors for that, but that's okay. I'm rolling with it. So there's angles, blah, 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 right? And angles are going to be measured in degrees, and eventually we'll talk about radians, which is another way of measuring that distance. Well, I guess that portion of rotation that we have there, right? That's what we'll be talking about.
It's the fish.
So an angle in standard position looks like this, where we're actually going to consider a coordinate plane, and an angle in standard position has its initial side. All right, the vertex will be at the origin. The initial side will be the positive x-axis, and the terminal side will be anywhere else, basically. Okay? And then my alpha would be here. All right, so that's an angle in standard position. And just to be clear, it's also possible to have it look like... All right, so there's the initial side, and the terminal side could be in different quadrants and such as well. Right. And actually, speaking of quadrants, it's also very important that we know the quadrants.
1, 2, 3, 4.
So
Left one's 1.
This one's 1?
I think so.
Incorrect.
Oh, right one's 1. Top
right one was 1.
Top right is 1.
Left
And
2.
top left 2, 3, 4.
3's on the opposite side.
No, back
Yeah?
down order, yeah.
That's stupid.
No, it works. And actually, part of the reason behind this is if you think about kind of north, south, east, west, the sun rises in the east and travels across our sky in this counterclockwise direction. That's right. Sun, the thing that we measure our time with, travels in a counterclockwise path. And that's because the shadow that it would cast on, say, like some sort of sundial would travel in the opposite direction, or clockwise. There you go. So that's why quadrant 1, 2, 3, 4. So it thinks about it in that way. And it turns out it's also possible for an angle to have a negative measurement. So, for instance, say this is say alpha here. I don't know. Let's say this is like 70 degrees. All right, this alpha would be like, I don't know, maybe 135 degrees, something like that. It's also possible to have angles land right on our quadrants. So what angle do you think that would be?
90.
Yeah, alpha would be 90 degrees. And if it lands exactly on a quadrant, by the way, it is called a quadrantal angle. Nope, I just spelled that entirely wrong. Quadrantal Just so you know, make sure you're spelling angle and not angel. And also, guys, if you're ever writing a Facebook post to a girl and you call her some sort of angel, make sure you don't say angle. You'd be surprised. People spell those wrong all the time. So quadrant.
What if you call her a cute angle?
That'd be perfect. That'd be fine.
Oh,
That'd be fine.
cute.
So that's at 90. This is 180 degrees. This direction right here, what angle would this be? If I spun all the way around here.
240.
No?
270.
270 degrees. And then what's one full revolution?
360.
360 degrees. So hopefully my snowboarders and skateboarders will be good with angles. Boaters. Snowboarders. And it turns out that we also can have angles measured negatively. So right here, it turns out alpha can have a negative value. So alpha would be like, this would be, I don't know, we'll call that negative 120 degrees. Something like so. So, and it's anytime an angle measurement is negative, it would travel a clockwise path. Okay? So, make sure you have that kind of.
120.
Negative 1.
Yeah, negative 120 degrees, something like that. Now, it turns out, I guess I might be jumping ahead a little bit here. That's okay. Well, it turns out there's actually more than one way, bless you, to label an angle.
You're blessed, Jess.
It turns out not only is this the angle negative 120 degrees, I also could have thought of it as the angle,
R.
what's this going to be, 240 degrees. And not only could that have been the angle 240 degrees, this also could have been the angle.
I feel like.
What angle do you think that would be?
360.
I think that would be 500 degrees. It'd be 240 plus another 360.
Why would you do that?
Why would you do that? Well, what if I was happening to,
The thing spun around once.
yeah, describe something that has multiple revolutions?
Like the sun.
Sure. So, now all of these angles, the way you describe these are called coterminal angles. All right, angles whose terminal sides are the same. The terminal side of the angle is the one that's not in the initial starting position. So here's a terminal side, here's a terminal side, here's a terminal side. This is the terminal side that they're sharing. All right, so where the angle stops, basically, is the terminal side, right? So those are called coterminal angles, right? Their terminal sides are companions, maybe. I don't know. So, could you name a negative angle that is coterminal with these buddies? What's a negative angle that's coterminal with these ones? Negative 120. What's another one that's negative?
Negative 1. I don't know. Whatever.
Right, if I spun this way.
Negative 500.
No,
Negative 240.
no. Negative 500 would have been like here.
So it would be negative 0. 90.
Negative 480, I think I was hearing, yeah. It'd be negative 120 minus another 360. So coterminal angles, I guess I could kind of show you this. How do I describe this? Coterminal angles, alpha is coterminal to another angle, alpha plus 360 times n, basically. Well, I guess I could use theta there. Maybe I'll do that.
Mr. Waddy.
Oh.
It's all right. It's all right. So theta is coterminal with alpha if it is 360 degrees added or subtracted any number of times. All right, so n is an integer. Okay, so 360, n would be the number of revolutions. All right, so n could be 7, and I'd add 360 to it 7 times. N could be -5, and I'd subtract 360 from it 5 times. All right, and it will just spin around and around and around and around and then stop in exactly the same location. Right? Right. So for instance, you would be no better at the game Twister if you spun it around like 10 times and it landed in the same spot as someone who spun it around once and landed there, right? You would just be showing off your awesome like ability to spin like a little pinwheel thing. What is it called? I don't know.
Pinwheel death.
Who knows what those... Pinwheel would be like the thing you have in the wind. It doesn't matter. A spinner. It's called a spinner. We'll call it. I'm calling it.
Pinwheel.
Spin wheel? I don't know. Look it up on the internet. You're already online. So anyways, so that's a bunch of stuff to do with angles. One more kind of angle I want to point out is a reference angle. Reference angles. And these will not seem very important now, but these are the building block of like trigonometry. Yes, trigonometry is your life. Yes. So reference angles. Let's see if I can describe this. Actually, I think it was a really good. It's the angle. Let's see. I'm going to skip. All right. Reference angles are. It's the angle. The acute angle. Tell you what. Formed by the terminal side and the x-axis. Ba-blam. So, acute angle formed by the terminal side and the x-axis. So let's find some reference angles. Find the reference angle. So what if, now, oh, by the way, I think I had theta show up earlier. It's like a 0 with a little line through it-ish. So what if theta is 70 degrees? What if theta is 154 degrees? What if my initial angle is... let's say negative 132 degrees, maybe. Yep. And the last example we'll do is theta is 330 degrees. So let's find the reference angle for these guys. And it's actually a really good idea to draw a picture.
Yay.
So, where is the terminal side of a 70-degree angle? Which quadrant? Or maybe it's quadrant, right? It's the first quadrant. Now, if this is 90 degrees, I think of this kind of 70 must be somewhere around here, right? 45 degrees is your classic 45-degree angle right there. So here's 70 degrees, right? So my reference angle is formed by the terminal side and the x-axis. So, would it be this angle? Or what's wrong with this according to the definition? It's not acute. So, because I have two choices. There are two angles that...
One's obtuse.
Right? One is obtuse in this case. So I'm going to choose the one that's acute. And what is the reference angle in this case? 70. So that's not that interesting. Right? So in quadrant 1, Your reference angle is your original angle. All right, here's a quadrant 2 angle. Oh, I just gave that away, I suppose. That's okay. So 154 degrees. Now 135 degrees would be like a 45-degree angle there. So 154, I'm guessing, is something like that.
Does that have to be that accurate?
We'll try. Eventually, I mean, we do have a protractor that we could use.
One.
We have one, yep.
One.
So there's 154 degrees. So what is the reference angle here going to be?
26.
26. How do you find that? So it's the acute angle to the x-axis, right? So alpha, and how do you get 26?
It's 180 minus 1.
Right? So 180 minus 154, that's 26 degrees. So it turns out for quadrant 2, if you wanted a formula, your reference angle would just be 180 minus your angle, your original one. So it's a little bit different for each quadrant. That's why I do recommend drawing a picture, but if you did memorize these formulas, that would also work just fine for you. Let's see, which quadrant is this one in?
Probably, I'm guessing 3.
Third. So let's see, negative 132 would probably be almost 45 there. So negative 132 degrees. So which way is the reference angle?
Up.
Right, that's the closest. Well, our reference angle has to be acute by definition. Acute angles are from 0 to 90. So we'll have to figure that out. What I could do is, in this case, let's find a coterminal angle maybe. What's the coterminal angle? I could do 360 minus 132. That's 260, 228. Is it?
Why you doing that? Why don't you use subtract 180 minus 132?
That would also work. Yeah, there's multiple ways of looking at this. But if I do my angle, I'll use my coterminal. Theta minus 180 in this case. So 228 minus 180 is 48 degrees. All right, so for quadrant 3, you'll take your kind of positive angle anyway and subtract 180 from it. And yeah, if you had the picture, I agree, 180 minus 132 would also have given it to you there.
So it's not negative even though you continue going that way?
Reference angles have to be acute, so we've got to be positive. And since they're kind of building blocks for us later, that's why we want to have them the simplest possible way. Let's see, 330 degrees, what quadrant's that in?
Oh, that's the one first.
4.
So here's 330 degrees, little Pac-Man right there. Right? And the reference angle is this right here. Right? It's not going to the negative x-axis this time. This time it's going there. And so to find alpha, what do you think I could do? 330 minus 180?
360 minus 330.
330 minus 180 would give me this angle. Right? So I'd want 360 minus 180, or minus my theta. By the way, that's Theta, theta is how that's spelled. Theta. Yep, that's why I realized I should probably say it out loud.
Can you say that?
Theta.
Theta?
alpha. Yep. So there's some basic stuff with angles, coterminal angles, reference angles. Those are going to be really important stuff that you're practicing tonight. The other skill that we'll do a little bit of is talking about degrees, minutes, and seconds. Let's see, I'm going to scroll over here. I technically was supposed to start with this, but whatever. So let's see. So degrees, let me write some facts about that. So there are 360 degrees in a revolution. All right. And it turns out that if I take a degree and divide it into 60 parts, 1/60th of a degree is equal to 1 minute. That's like a little apostrophe, I guess. And if I take a minute and divide it into 60, I'll get a second. So 1/60th. Actually, I put that degree mark in the wrong spot. 1 degree divided by 60 parts, sorry.
Wait.
And 1 minute divided by 60 parts will be 1 second.
A minute is a 60th of
A degree.
revolution or a degree?
Of a degree.
So that's not 360 right away.
Correct.
That's what you said it was.
Did I?
Yes.
Oh, sorry.
Ah, you're crazy.
Well, so a degree is 1 revolution divided by 360 parts. You could think about it that way. Is equal to 1 degree. A minute, if you divide a single degree into 60 parts, you get a minute. And if you divide a minute into 60 parts, you get 1 second. And what's even worse is that we denote minutes with kind of the foot notation, and we denote seconds with the inches notation. What were they thinking? What were they thinking? So, yeah. Holy smokes. So let's see. And actually, if you have a GPS unit and you ever do any stuff like that, let's see. Actually, I want to do example. Sorry. You can actually have your GPS unit read out in minutes and seconds regarding latitude and longitude. I have mine convert to decimal, so it's degree only. But convert to minutes and seconds. So I think the bell's going to ring soon. The homework's on the board, though.
Mr. Waddy, can I get a computer for my
Yep, he'll be able to do that.
Because I have to go down there anyway because that's my end.
So what if I have 25.17 degrees, and I want to figure out what is that in degrees, minutes, seconds? Well, this is what I would do. I would take 25 degrees, and I know that 0.17 divided by 60 will become minutes. Okay? So I'm going to do 0.17. Mis calculadora. 0.17 divided by 60. Wait a minute. It's very small. Very, very small. That's okay. Yeah. Nope. Darn it.
Wow, saggy.
Darn it. 0.17 times 60. Silly me. Silly me. That's for the conversion the other way. La 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 la. Yeah. Yep. So I'm going to keep doing this problem if the bell rings, but it'll be cool. So 0.17 degrees times 60 will give us our 10.2 minutes. So this is 25 degrees, 10 minutes, and if I want 0.2 minutes to be measured in seconds, what could I do with that? Multiply it by another 60. And 0.2 times 60 is 12. So it turns out this is 25 degrees, 10 minutes, and 12 seconds. And then to go backwards, I would end up dividing by 60 to go from seconds to decimal version of minutes, and then divide by 60 again to convert from decimal version of minutes to degrees. Right. So, anyways, there we go. And what do you know? 25 minutes, 54 seconds.